Okay, I'm going to show how to calculate the correlation coefficient in SPSS, and I'll give us a little bit of practice with data entry. Just use the really simple example, the correlation between number of cats and number of dogs. So you can pause the video if you're getting ready to, you need to open up SPSS. And now you got SPSS opened. I'm going to enter the data into SPSS. But first I'll define my variables. So I toggle between a variable data view and variable view right here. And my first variable I'm going to call, I can't call it number of cats. If I try that, there'll be two problems with it. I got spaces and I have the @ sign or pound sign, whatever it is, invalid variable. So I'm just going to call it quite simply cats, and I can label the variable, and in my label I can call it number of cats. There, I have complete freedom to do as I please. And I'll do the same for dogs. Can't do number of dogs because SPSS will not accept it. And I don't need any decimal places. And I'll call it, label the variable number of dogs. I will now enter in my data, fairly straightforward, 3, 4, 1, 2, 4, 6, and number of dogs, 5, 1, 6, 3, 2, and 0. Okay, I have my data in. It is quite easy to calculate the correlation. All I have to do is go into Analyze, Correlate Bivariate, and just pick my two variables. And I can get my, if I want, my means and standard deviations. So I can see here, what you have to do is, what SPSS does, so in this column here, this box here, all the available variables, and I can pick them. I can pick all of them by just clicking on them, and then there's an arrow here that moves variables back and forth. So here's the available list, and then if I move them into here, they're in the active list. I will be calculating the correlation between those two variables. And I click OK. I don't need to flag significant correlations. And do I even want significant? I don't know if I can do that. Cancel, and let's not get too fancy here. And I'll just calculate Pearson's R correlation coefficient. Okay. Now it does it. It calculates the means and standard deviations, and there's my correlation of negative 0.87. What you see here is referred to as a correlation matrix. And the reason it is in this format, even though it is hugely redundant, because the correlation between number of cats and number of cats is 1. Yeah, okay, that's not rocket science. And in the bottom right quadrant, the correlation between number of dogs and number of dogs is 1. That's kind of like, okay, not too informative. But the reason it's in this format is that's just the style that it was in, because it's tied to matrix algebra. So it's a correlation matrix. And it's a huge amount. I only need one number out of here. I need the negative 0.87. So the correlation between number of cats and number of dogs is kind of like the same as the correlation between number of dogs and number of cats. It's redundant. It's just putting it into a square matrix. So I just need this one number here, the negative 0.871. Okay, so I know it's a bit confusing, but that's how you read the correlation coefficient in SPSS. And there is no simple way to calculate it like you can in Excel, because SPSS, you can't do it the way we did it in Excel, because there's just no like summing and all that. The summing is a royal pain. I could do it computationally, but we're not going to do that. Not yet, even that wouldn't be fun. Okay, so that's using SPSS to calculate the correlation coefficient.